Alright, so we just looked at a question on delta math. It's simplifying these rational expressions. It's an expression because it does not have an equal sign. And if you see that if I just put this into my calculator, just as I see it, it will spit out 784x squared. Just so that you know, let me make sure that I inputted this correctly. Oh, I did not. So what mistake did I make? I multiplied instead of added. So let's go back and fix this real quick. So I'll just press enter to copy it. I'll scroll back, change this to addition, and there's my answer. Okay, but the way they want this simplified is going to be the following. When you have one term in the denominator, you can do this right here. You can break these up into two terms, into two fractions, that is. So I have this and that. So these will cancel to a form of 1. This will reduce to 4. And 196 over 7 can reduce to 28. So this right here can become, there's 2 up top, there's 3 on the bottom. These knock each other out, the bottom one wins. This could be my answer that's expressed. Okay? And what you see here is that they've combined it. The calculator automatically combines it to one fraction because they have a common denominator right here. So the common denominator is x. So it'd be 4x plus 28, which is what that would be if you distributed it out. So I believe that you can insert as an answer into delta math this, and it would accept it. You can enter the 4x plus 28 all over x, and it would accept it. Or you could do something that's a manipulation like that. Okay? Alright, so we can try another one if you'd like. Okay, yeah, that one's different. Okay, let's do this one. So this one is possibly on the non-calculator, probably the last 5 to 10 questions. And if it asks you to simplify this, what do I do first? Brandon, what would I do?
Would the x squared cancel out?
These cannot cancel out right now because the only place that you can cancel is between multiplication. So if that was multiplication, like these were parentheses, and this was multiplied with all of that term, then these could cancel out. But because it's addition, you can't cancel this that way. Okay? Do you understand what I'm saying by that? So if I had 3 times x squared over x, I can cancel that to 3x over 1 because the x is canceled. But if it was adding, I can't cancel this just to 3 because I can only cancel between multiplication, not addition. See, if I have this addition, I have to break this up into two pieces. Like we did that other example just now, that I would get 3 over x plus 1, which is not the same as that. Okay, so that is a common mistake, trying to cancel between addition and subtraction rather than multiplication. So what you're going to try to do is you're going to try to factor this. You're trying to factor this so that you can create multiplication pieces right here and here. Okay, some of you are probably doing this in class right now. What is this factor to? X plus, say again? 1. 1 and for this one?
Oh,
no worries. So we know that the first 2 will multiply. So let me highlight it real quick. The first 2 terms on the top will multiply to get x squared. So those are x and x. And then the last 2 terms will multiply to get negative 40. So I need 8 and 5, or 1 and 40, 2 and 20, 4 and 10, right? So I want them, whatever I choose, to also add or subtract to give me 3. So 8 and 5. So it'd be, oh, and -5, not 3. Yes. Nice job. So here we go again. On the bottom, first ones are x. What would the other ones be? Multiply to give me a 16, but also add to get me that 6. 8 and 2. And what are the signs? Positive or negative? So a -2, +8. Yep. So when you see simplify, they're trying to see, do you know where the cancellations occur? See, with Brandon, what we were just doing moments ago, we can't cancel that because addition is right here. But I can cancel the whole thing to a form of 1 because multiplication is right there. Okay? So my answer would just be x minus 5 over x plus 2. Okay? So x minus 5 over x plus 2 will be inserted as the answer. And again, because this is subtraction, I cannot cancel there. I can't cancel there, okay? You can only cancel between what? Multiplication. Between multiplication pieces. Alright. Let's see if they have variations of other ones. Will it not give me a new problem? Oh, that's weird. Let's go back over here. Let me see if I click on it. Okay, so we did one that looked like that. Okay, so this is another factoring one. Let's get some practice with some factoring, okay? When you have fractions and you see this word, most often than not, you're going to do that first so that you can find those pieces that you can cancel to 1. How can I factor the top? Any one of you guys. What do I do? What do I pull out, or what do I do? Pull out x squared. What's left? X plus 4. Yep. And on the bottom, can I pull anything out? Nope. But I can factor right now, right? To what? We should be doing this around class right now, probably. 4 and 4, right? So x plus 4 and x minus 4. This will be a positive and this will be a negative when you have a difference of squares. Okay, so difference of squares, this is a positive, this is a negative, because the first two terms will give me x squared. The last two terms will give me 16. And a positive and a negative 4, guess what they give me? They give me 0. That's why you don't see an x term there. You know what I mean? Standard notation is ax squared plus bx plus c. There's nothing there. There's no x there. What's a? What's a down here? I want to review from what we did with quadratic formula, I believe, last time. What's a? 1. What's c? Negative 16. And then b is 0. Cool. What's a up top? There is no a. Because a, b, and c are only with quadratics that are x squared, x, and a number. This one's a cubic function. So you can't do it without it, per se. Okay? Alright, so what cancels? X plus 4. The whole thing cancels, right? So that my final answer would be what? X squared over x minus 4. Cool? Alright, so let's see if we can find other ones. Maybe one more on this section that we haven't done yet. that. Yeah, we covered them all. See how difficult that they get. How do I factor out the bottom? X plus 1, x minus 1. How do I factor out the top? X plus 6, x minus 6, right? Because there's no b term. Okay, so difference of squares. All right, cool. Let's go now to rationalizing denominators with the square root on the bottom. So if I have something that looks like this, and I asked you to rationalize the denominator, your goal is to get rid of the square root in the denominator. And I've told you since day one, the best way to get rid of a denominator is to multiply by the denominator. Now I'm going to multiply by a form of 1. Why is it that I had to do a form of 1 and I couldn't just multiply by just that? Why did I have to do a multiple of 1? A form of 1? Because there's no equal sign. If there was an equal sign, let's say that I had 1 is equal to 2 over root 10y. If there was an equal sign, then I could multiply both sides by this, where these would cancel. And I'd be left with root 10y would be equal to 2. But I don't have an equal sign, so I have to multiply by a form of 1, because anything times 1 is still the same thing. It just looks different. Okay? So the reason why I did that is because a square root times a square root will go away. And what are you left with on the bottom? Not 1 on the bottom. Just the bottom piece, not reducing. 10y. Oh, did you say 10y?
Yes.
My bad, I heard 1. Okay, no worries. And what do you get on the top? 2 root 10y. Perfect. And you'd be done. Because all rationalize the denominator means is try to get that square root out of the denominator. Okay? I wonder if they have one with imaginary numbers. Let's see real quick. Because we've talked about imaginary numbers, right?
Yes.
A little bit. Let's see. Okay. I think they're all pretty much the same. Well, what form of 1 would I multiply this by? Over root 4t to the 5th power. Yep. So whatever the denominator is, you're just going to make a form of 1 and multiply the numerator and the denominator by that. So when these multiply, what's my new denominator? 4t to the 5th. What's my new numerator? Yep. And then technically this 4 can come out as a what? As a 2, right? So you could have 2 outside, t to the 5th. We talked about this last time too. Because remember, let's see if you can remember, what number is understood to be right there? 2. So pairs will come out. So this t to the 5th, how many of these t's come out? 4 of them, but they come out as t squared. Yeah. So they'll come out as, it'll look like this. 2 t to the 3rd times 2 t squared, and 1 is still in there. What do I do from here? Multiply the 2's to get 4.
And then you add the t's.
Add the t's to get 5. And then
You're left with root t.
root t. Because these cancel to forms of what? Or to 1, right? Yeah, whenever you cancel with multiplication, they cancel to forms of 1. Because something over itself is 1. Questions? Okay. How about are there any more that you guys want to touch base with from Delta Math? Or the reading? Where do you want to go? You tell me. Yes?
So on this one, how do they like get rid of the 6 and then how did that turn into a 3? I think this is just a couple edits, but
The 3 and the 6. Where do you want me to start? You want me to start here? Or
I don't really know because wouldn't it just be D2 plus B3 the B6 or
oh, okay, so b squared times b cubed is b to the 5th.
okay. So in this case they had square root of B6 and square root of 30 like right here.
Okay.
And then the next step that they had was B squared.
Oh, okay. So they had b squared, b to the 6 square rooted, and was the 30 under there too?
Yes.
Okay. So the 30,
A 7.
oh, a separate one.
Yes.
So it looked like that.
Yes. Over 30 B6.
Over 30 b6. Whoops. Alright. So a good thing to remember is that powers that are multiplied with the same base will add. But if I had just one b that was raised to the 3rd power, this is when I would multiply. Over here, this b to the 6th means that there are 6 b's right here. And when they come out, this pair will come out as one of them. And then this pair will come out, and this pair will come out. So when they come out, they're gone here, and only one is left. And b cubed came out. So that's what this becomes, b cubed. This is b squared, and I have root 30.
Alright. That would,
And then you see that, how many do I have here? b5, right? b to the 5th power. So 5 versus 6, who wins? The bottom one by 1. So you would be left with that.
okay, that makes sense.
Okay? And if you see something like this, let's do a couple. What did we say this equal? Anyone? b cubed? What if I had b to the 11th?
B to the 5th and there would be 1 B.
b to the 5th, and then 1 is left in there, right? Because they came out as pairs. And the reason why you can do this is, well, let me change it up. What if instead of square root, you had a 3 there?
So they come out in pairs of 3?
Yeah, in groups of 3, they're going to come out. You see what I'm saying? So how many b's come out? 3. Yep, so it'd be b cubed. How many are still in there? 2. Does it make sense, guys? Now, I don't think you'll see something like to the power of 4. Okay? But this is very important because let's say that you have a number that looks like this. And this was on the non-calculator. And it was a piece of a problem, and it said 8 to the power of 4/3, non-calculator. What is that number? What's 8 to the power of 4/3? How do I figure that out? There's 2 ways you can look at 8 to the power of 4/3. I can look at it like 8 to the power of 4, and then cube root that, and that would look like this. me? What we just talked about, what does that look like? How many 8s would come out? Just 1. How many would be left in there? 1. So it would look like that. You with me? Now, what is the cubed root of 8? I'm not saying what is 8 cubed. I'm saying what is the cubed root of 8? There is one. What number times itself 3 different times would give you 8? 2. So this cube root of 8 is 2. You with me? So 2 times the 8 that's already out here, this is 16. There's an easier way, but I wanted to show you that way so that you understood what this number means. There's an easier way. Look at this. Not only could you do 8 to the power of 4 and then cube root it, you could do this. What is the cube root of 8 first, and then raise that to the power of 4? You see that? That one's a lot easier because they're interchangeable because multiplication doesn't have order. It's still the power. It's still the root. But if I break it down to its root first and then raise it to the power, it's a lot easier because what's the cube root of 8? 2. What's 2 raised to the power of 4? 16. Because it's this 4 times 4, 4, 16. Okay? A lot of people struggle with fractional exponents. I just want to make sure that you understood them, not only with letters, but also with the number terms. Okay, what else? Yes?
Number 8 on page 245.
Number 8 on page 245. Alright, so if Alex can fold 12 napkins in X minutes, how many napkins can he fold in Y hours? So, let's go ahead and put napkins per minute. And how many can he fold in Y hours? Okay, so first of all, well, if I want to make this, right now it's napkins per minute. Do you agree? Okay. And we want to know how many he can make in Y hours. So first of all, let's convert this to hours. Do you understand? Okay. So if I convert this to hours, I'm going to do some dimensional analysis. They're just ratios, they're just fractions. It's just a fancy word for just fractions. My goal is to get rid of minutes and to now have what? Hours. And fractions are why people don't like dimensional analysis. If I want to get rid of minutes, and minutes is on the bottom, that means I'm going to have to put minutes up here and hours right here. What do I put for minutes? 60 for 1 hour. You with me? What's happening right here? Multiplication. So now these will cancel, and my units are how many napkins can I make in 1 hour? Does that make sense? So now, multiplying straight across, we have what? 720 napkins. And multiplying straight across on the bottom, I have what? Or X hours, right? So if I'm making 720 over X, 720 napkins over X hours, and I want to do this in y, what am I going to do? If I can do this many napkins per hour, you with me? And I want to know, okay, if I can do this many napkins per hour, how many could I do in y hours? You with me? So when I multiply by y, and technically it's y hours, which is y hours over 1, what happens to the hours? They cancel. And all you're left with is napkins. So it would be multiply straight across. That's how many napkins you would do in y hours. Does that make sense? Fractions for sure. What else? That's a good question. Some of you are too quiet, guys. You need to have questions. Yes?
18 on 245.
18 on 245. Okay. So, percentages and fractions we have. Here we go. A is 63% of x. So A is 63% of x. You with me? And C is 3/8 of x. What does of mean? Not division. Out of means division. But of means multiplication. Okay? Here we go. This is very important right here, what I'm about to say. There's regular math, and then there's probability. In regular math, what we're doing right now, of means to multiply. Okay? And in fact, let me do it like this. Multiplication, the word in regular math is of. The word in probability is and. In regular math, addition, what do you think the word is to add? What do you think? It's and. Okay? Notice in probability, and means to multiply. But in regular math, and means to add. And, oh, no. No worries. Close. I'm going to build off what you just did. Okay, so it's almost of, it's or. Okay? So the word in probability is or. Hopefully that helps you remember. Okay.
Oh my god.
No worries. So I said A equals 63% of, so here's of, and if you know how to build the equation, these are pretty much straightforward. Here we go. Which of the following is the closest to the ratio of A to C? So my goal is to get A to C, which is the same as A to C. So all I have to do is put A to C, and I'll be done. Here we go. A is that. C is that. Okay? So what could I do to get my ratio to one of those numbers? What do I do to this fraction that I just set up? Y'all understood up to here, right?
Yeah.
Okay. What do I do with the x's? They cancel. Because it's multiplication to multiplication. See that? So they're gone. So all I'm really looking at is, what is this over 3/8 going to be? And this would be a calculator problem. Okay? So in my calculator, 0.63, so we go control divide 0.63 over control divide, and then we're just going to put 3/8. And then you get 1.68. Do we understand? That was still a good one though, because those are a little weird as far as how they set up sometimes. Okay, let's keep looking. 25 where? 246.25. Alright, so there are K gallons of gasoline available to fill a tank. So we don't know how many, there's just K gallons. After D gallons have been pumped, in terms of K and D, what percent of gasoline has been pumped? Okay, so let's pretend that we have this tank and it has my K gallons in it. However much it is, we don't know. We just know that this gasoline's a little dirty. But I know that there are K gallons in here. So when I pump this D gallons, I'm removing the D gallons. We want to know, in terms of K and D, what percent of the gasoline has been pumped. Okay? So my total right now is K. Do you agree? And a percent is like a piece over the whole. So think of a slice of pizza over the whole pizza. This is your percent, right? So a piece over the whole. My whole over here was what? What was my total? What was my original total? Okay. That's my big pizza. What's the piece that's left? Because it says, in terms of K and D, what percent of the gasoline has been pumped? Like, we want to know what percent has been pumped. What percent has been pumped, guys? If I put K minus D, is this how much has been pumped? No. What does this represent? How much is left in the tank? You with me? So what do we write down to show how much has been pumped? Just D. Just D, right? D has been pumped. You with me? So the amount that has been, because it wants to know what's the percent of gasoline that has been pumped. The thing that has been removed, if we were to count that, how much got removed? In other words, let's say that you had an empty tank and you went to the gas station. This is the gas station, okay? And here is your car per se, okay? Almost, right? There's the car door, whatever. And here's you. Yeah, I know I'm crazy, right? And you're pumping, and it's cold outside, so there's wind blowing your hair. But you're like me, so you have a little bit of hair. All right, so you're pumping your gas. So the actual amount that went into your car was the amount that was removed. You with me? So, and this is what we're looking for. We're trying to see the percentage that was pumped. Okay? What percent is this? 50%. If I put this in my calculator right now, I get 0.5. You agree? So how do I make 0.5 say 50%? How do I convert a decimal to say 50%? What would I do? What would I do to the left side? I know I moved the decimal twice, but what do I mathematically multiply or divide the left side by? Do I multiply or divide by 100? I multiply. Multiply makes it move to the right. Dividing makes it move to the left. You with me? So multiply makes it move to the right. So this is going to be moving it to the right. Do you see where I'm going with all this? So if I multiply this, I'm now changing this decimal fraction into an actual percent form. So what would the answer be? Those are tough. A lot of times percents, because we don't have enough practice sometimes changing decimals to fractions to percentages. Cool. All right, what else? We have time maybe for 2 more. 21 on page 245. Okay. Then which of the following is equal to 1 over c? Okay, so 1 over x plus 1 over y is equal to c. And they say that x is greater than y, which is greater than 0. This is the same as saying y is between 0 and x. So we're trying to find 1 over c. What do y'all suggest that we do right now? How would y'all start? I'll fix it if you're wrong, but how would you start this? Because your goal is to get this. Multiply by 1 where? Okay, I see what you're saying. So we can multiply by things to get rid of denominators, but you can't multiply by things to get rid of the numerators per se. I mean, you can, but they're fractions. Okay, so here's what I would say. When you said multiply by a form of 1, I thought you meant this. Okay, look what's about to happen. We are adding fractions. You agree? We are adding fractions on the right side. And the way you add fractions is ooh, what just happened? You need a common denominator. Yeah, that was weird. You need a common denominator. And the common denominator, oh, that's what I did. I pressed that. Would be right there. So your common denominator right now is y over xy plus x over xy. Those are still both xy's because order doesn't matter with multiplication. Is equal to c. You with me? In 5th grade you learned I can bring these two together and write them as 1 with the same common denominator. Or you could have written it as x plus y over that same common denominator. You all see what I did? And last but not least, we want 1 over c. So to make this say 1 over c, because right now, what does it say? c over 1. All I have to do is flip. Take the reciprocal. So when I take the reciprocal over here, I'll have xy over x plus y, which is d. Okay, so first, get multiple fractions into 1, because from geometry, you're trying to get something that looks like this. A fraction equals a fraction. And from there, we're going to take the reciprocal. You could have done cross multiply and divide, but it would have been the same thing. let's do, let's keep going. We have about 5-7 minutes.
12 on the same page.
12 on the same page. So nails, oh, this is kind of disgusting. These aren't, I was thinking like, this is nails like, never mind. Nails are sold in 8-ounce and 20-ounce boxes. All right, here you go. So we have, let's say, 8-ounce box. And these are nails like construction nails, guys. Right? I was thinking fingernails. And 20-ounce boxes. Let's do this one. I didn't think it was so funny, but okay. Alright, if 50 boxes of nails were sold and the total weight of the nails was less than 600 ounces, then what is the greatest possible number of 20-ounce boxes that could have been sold?
You're making it worse.
You ready? 8x, 20y. So this one is a systems of equations. System of equations has two equations. One might be money or weight. The other one is the number of items. Okay? So, it says, what is the greatest possible number of 20-ounce boxes? So 50 boxes of nails were sold. Here we go. 50 boxes of nails were sold comes from that. That's your items, your amount. And then the ounces, money, they like to do a lot of money with this too, but ounces with weight also works, was less than 600 ounces. What's going to go to the left of this? What would I write to the left of this? So you see how this is the number of items? Like x plus y would equal 50. Here it's going to be 8x plus 20y would be less than 600. You see what I'm saying? Like the coefficients with weight, whatnot. Questions so far? So this is a calculator permitted section. So all I need to do now is solve the systems of equations with the calculator. Let me take a picture of this so that I can use the calculator to show you guys. We are going to do, follow me. So mini 1.4 just clears it. Mini 1.5 clears it so you have a nice clear screen, okay? So menu 1.5. From here we're going to do menu, 3 for algebra, 7 to solve the systems of equations, and 1 to solve the system. I have 2 equations, so I'll just press enter. And now just put 8x plus 20y. I know it says is less than, but you could put equals to if you'd like to. And then you could do x plus y is equal to 50. And the whole numbers that exist, if you wanted to give them like in decimals, just press Control Enter, and that'll show you where those lie as far as answers are concerned. I could go up all the way up here and press Enter to copy it. And if you felt more comfortable by putting that less than, you could change this to Control equals less than. But you get these weird answers right here. Okay, they just don't make sense because you have an inequality with something that's equals to. So to me, that's why I go over here where they're both equals, so that I can see where does that threshold lie. Okay, so 33 is 16.6, and it says what is the greatest number of 20 ounces? Boxes. So the 20-ounce boxes, guys, came from the y. You with me? So we're trying to find the y, and what would it be? 16. And it has 16.6. Do I round up to 17 is the question. Think about this. If I have 16 here, what would you do with the other one? Would you put 33? Do you see what I'm doing? So if I put 33 here and I put 16 here, first of all, they don't even add to get 50. You see what I'm saying? So you need to say that. Well, let me show you, let me show you a different way, just so that you can see what math is happening, so that you know how to interpret the calculator, okay? We're looking for y, aren't we? We're looking for y. So over here, if I said x is equal to 50 minus y, substitution from the second equation, I can put this up here where x is at. So then I could say 8 times 50 minus y plus 20y is less than 600. Does that make sense? So now, everything is in y. So let's put this in our calculator another way and look for the calculator to spit out my answer of y. Okay? So let me take a picture of this. This will be our last problem, okay? So going back to our calculator, it will look like this. Menu, 3, 1. You're going to do parentheses, where it already has it. 8 times parentheses 50 minus y, close parentheses, plus 20y is control equal to less than 600. And then comma y, because you're looking for y. So you just need something that is less than 16.6. So it'd be 16. Does that make sense? I think that one is more reliable than to try to look at both case scenarios. So a substitution on that, finishing off the calculator. Again, what's for homework, guys? Chapter 14 and Delta Math. Please show the growth. Be ready to show the growth when you guys come on Monday. All right.